So I pretended like I was going to be able to fit in how to write an equation from a scenario or a word problem in the last video. Because my videos can only be 15 minutes, I did not want to try and rush that in there. So we're going to talk about it in its own little section. So when we're given a word problem, which I know we love, the first thing we want to do when we're trying to create an equation from the word problem is just try and think about it logically. So that's what these steps are helping us do. So my first step is to identify the independent variable. Almost always, if I am using time in my scenario, time is usually the independent variable because time is not dependent on anything. Time just happens. So if time is involved, that is our independent variable. We also need to identify our dependent variable. Our dependent variable, a lot of the times, is money. So if a great example of figuring out what my independent and dependent variable is, a pay per hour. So if I make $15 per hour, I know that my dependent variable, what's changing, is the amount of money I make, and that changes. It's dependent on the number of hours that I work. So that helps us identify independent and dependent. This does not go away. It is super important for lots of levels of math and science and so forth. So that is a really important concept to try and understand when we are given a graph. Our graph, just a little more background information, has an x-axis and a y-axis. We already know that. The x is going to be our independent, and the y is our dependent. So it's going to be time and then money. So that's just a really important way of thinking about it at first. Then we're going to think, okay, what is my rate of change? How much does my dependent variable change when my independent variable changes? So that example we discussed in this first step was $15 per hour. My rate of change is $15 per hour because per one increase in the number of hours, I get paid $15 more. So that is what gives me my slope. That is going to give me the number that is attached to the M. And my third step is to identify what our initial value is. So our y-intercept can also be called the initial value, and it can also be called our starting point. So I'm actually going to highlight the important words when we're talking about this. So we've got our y-intercept, which we also call our initial value, and we already know about it as B. And then for our slope, we know that that is also our rate of change, and we call that slope, and that is represented by the letter M. So when we're looking at an example, my example that I just wrote down really quickly, which you don't have to write down, is at an ice cream shop, customers pay $3 for a medium ice cream plus 75 cents per topping. So my first thing that I need to identify is my independent variable and my dependent variable. What is changing is the cost of my ice cream. The cost of my ice cream is going to depend on the number of toppings I put on it. If I want to see this just numerically, I can think about it as, okay, this is going to be how much my ice cream cost. So if I have some number of toppings and I'm thinking about the cost of my ice cream, that's how I can think of the relationship changing, right? If I have 0 toppings, my ice cream is just going to be that $3. If I have 1 topping, it's going to increase by 75 cents. And then it's going to become $3.75. If I have 2 toppings, it's going to increase by another 75 cents, and I'll end up at $4.50, and so forth. So what's happening here is, without really knowing, when I'm just thinking about it logically, I am noticing that the thing that is changing, my dependent variable, which we already said is money if money is involved, is changing 75 cents per increase in one topping. So that means that my rate of change is going to just be 0.75 because I'm increasing that amount per increase in X, per increase in my number of toppings. My starting point, what my initial value is $3. Because before I even add any toppings, I know that the cost is going to be at least $3. So if I want to look at this as an equation, I just need to plug in that information that I just found. So I have y equals mx plus b. We know that our y is going to stay there and the x is going to stay there. 0.75 is going to replace that x. And then 3 is going to replace that b. And in this scenario, I know that y is our dependent variable. Y represents how much my ice cream is going to cost in total. And my x is my number of toppings. So hopefully with more examples that we look at, this will start to make more sense. So I'm going to just have us do one more example. I'm going to have us look at Marshall, since we just did the ice cream topping one. So this scenario, says Marshall earns a salary of $36,000 and each year he receives a $4,000 raise. So just like we did before, I want to think about this just logically. So if I'm Marshall and my salary, my first year is $36,000, that's my starting point, right? So I've been at my company for 1 year. I have made that much money. I know I'm going to increase $4,000. So what I can start to think about is that first year, I'm getting paid $36,000. The next year, $40,000. The next year, $44,000. So I know that the amount I'm getting paid is changing per year. So my independent variable, because time is involved, we know that the independent variable is time. It's our years. And the dependent variable is just the amount that Marshall makes in a year. So if I go to write this equation, I know the general form of my equation, y equals mx plus b. I'm thinking about what is it that is changing. What is changing is my total salary, and that's changing by $4,000 each year. So M is going to be 4,000. And then I am going to think about what was that initial value. In this case, my initial value, my starting salary is $36,000. So if I plug it into my equation, knowing that, I have y equals 4,000x plus 36,000. And this probably feels challenging. Hopefully it'll get easier the more you practice it, but it's really important to try and work out these problems on your own and then see someone do them so you can start to figure out how it is you should look at the scenario.